guys, welcome back to Rocket Gyan, my fellow space tubers. Okay, so it feels really good to be back after some glitch, but finally I have made it and I'm so happy that it is working all fine. And those of you who don't know, well, I was streaming the SpaceX launch just some hours today, and it was not working. But finally, we are here to see the Virgin Orbit launch, and this is kind of, you can say, a big launch of this year, because Virgin Orbit does not launch for a lot of time, but now it is launching. And that one more unique thing about this thing is that it is an air launch system. So we will discuss everything that you need to know about this launcher, the rocket, the payload, and everything. And just be there with me. You will enjoy this ride a lot. Uh, Hi everyone, hi Omkar, hi Austin, hi Alvaro, if I pronounce your name right, and hi Elburo. Thank you so much for joining in. So without any further ado, let's just jump into it, as in what this thing is all about and why air launch. So this is the Virgin Orbit, yes, that Virgin brand which you are all aware about, and what they are doing is they are basically trying to launch a rocket from an airplane. Yes, if you have just, you are new to this thing, rocket world, let me just tell you, yes, they are trying to launch a rocket from airplane, and airplane is none other than Boeing 747. And why are they doing this? What is the problem with the normal rockets that we have, right? So they are doing this for the small sat market. I mean, as you can see, this is how the things will look like. This is the plane, and then the rocket. It will take, the plane will take it to a certain height, and then drop this rocket, and then the rocket will go to the orbit. So this is how it will all work. But what is the advantages of it? First of all, for a small set, we have responsive scheduling, which means, like, today only, the best example is today, like SpaceX literally launched 105 satellites to the orbit, right? And 105 small sats, which were CubeSats, nanosats, picosats, and all those things. Now if you are like a customer of that, if you have like 105 sets, what you are restricted to, you are restricted to a common orbit, which means you don't have any flexibility. You don't have any flexibility in the launch time. Like, if you have if your payload is ready earlier, but you now have to wait for some time because the rocket is not available, or the, as you say, the plane is not the plane tickets are not filled. So it's like that only. But here what you are doing is, here you are taking just one thing to the orbit, like just one CubeSats, or like some pair of CubeSats, like that, because the payload capacity is very small, around 300 kg to 500 kg. So that's the thing which we have. Now the second thing they claim is the orbital performance. Well, yes, it is the case. The one advantage of air launch is that you can actually achieve any inclination, theoretically, literally any inclination. The problem with traditional launches which we have from the Earth is that they have to have some sort of launch windows, they have to have some sort of inclination, and they are restricted also. Like, if you are launching from US here, right, and if you want to go to an equatorial launch, which is like this one, this satellite is going 0 degree to the equator. Now from here, how can you launch directly to this orbit without changing any doing any further orbital maneuver? You can't do that, right? You can just go into some certain directions, like here, and here, but not in an equatorial plane. To go into in an equatorial plane from US coast, what you'll have to do is, you will have to first attain this kind of orbit, and then at this point you need to do some maneuvers to attain this point, this orbit, and this is very costly, very fuel costly. So what is the advantage of air launch? Well, airplane is can go anywhere, right? So airplane can just lift off from the pad, it can align it in the equatorial orbit, and then drop the rocket, and then the rocket can go. So you can literally achieve any inclination. Second advantage, you are literally avoiding all those weather constraints, because if there is any bad weather in a certain location, plane can literally fly on to other location. You are actually having a mobile launcher in air, so you can actually take, that's a launch pad. That airplane is a launch pad for the rocket, and that launch pad you are taking anywhere according to your will. So that is one more advantage. The third advantage I would say is that the fuel capacity for the ultimate rocket is decreased, because you are actually those uh, what should I say, the extreme losses which a rocket experiences in the low atmosphere. And in that atmosphere, the cosmic girl is taking care of, which means the airplane engines are running, and airplane engines are very efficient, so you don't have to worry about the rocket fuel. So this is the thing. So you are actually saving on the rocket fuel, saving on some everything. I mean, the advantages are limitless, but the disadvantage is that you can only have like certain weight to which you can tie up to an airplane. So that is the only disadvantage which I feel. But yeah, cryo fuel handling and all those things are there, but yeah, that is one thing. Okay, so hi everyone. So yes, let's hope everything is going good. And then this is, like they say, hardware rich performance, which means they have taken some proven hardware. So this is all about how they perform, and right now they are going in for 300 to 500 kilograms as a typical mass of the satellite. 0 degree to 120 degree is their inclination, which they can directly support right now. And 100% made in USA, 80 tons is the payload. Now let's just have a look at how the things look like during the launch process, right? So you can get to any orbit. This is a high orbit, medium inclination, and low inclination. Today it is going to a medium inclination orbit, which is a 45-degree orbit, which is exactly like this. So yeah, that is the thing. Now how the things look like. Payload processing. Okay, this is a thing which you have. Means arrival day, the payload is there, arrive onto the integration bay. Then you have meeting with the payload adapter, then the encapsulation in the fairing, and finally payload processing, which means you are checking everything is all right, and then final preparations. Then the rocket is transported to the launch site. The launch process, first of all, the Cosmic Girl, this is the name of this airplane, and yes, they have modified Boeing 747 for this one. And there are a couple of reasons why they have chosen this airplane, which I will tell you after some time, but right now that is the case. And so yeah, this is obviously, you can say, a reusable first stage which you can have. So first of all, the Cosmic Girl takes off, and then the rocket deployment happens. So this rocket deployment happens at 35,000 feet. As you can see, a chief pilot hits the big red button and releases the rocket from the pylons. So this is how the things look like. It aligns itself into a 27-degree inclination and then drops it at around 35,000 feet, which is quite up in the atmosphere. And then finally the first stage burn starts. So before the first stage burn starts, there is a 4-second free fall, and during this 4-second free fall, there are some, what should I say, fuel settling thrusters which are there, which as the name suggests, the role of those thrusters is to settle the fuel. Right now the fuel inside this rocket is not what should I say, towards the bottom of the engine, towards the bottom, towards the engine. Basically, it is not towards the engine when it is just dropped. When you have some thrust coming in from behind, then all the fuel is you can say dragged on to the bottom, which allows the fuel to finally come to the engine. That's why we have this fuel settling thrusters which comes into play just after you drop it. After 4 seconds of free fall, the first stage engine ignites, and the rocket starts to 8,000 miles per hour, which is this things. This LauncherOne rocket is a 2-stage rocket, so the first stage is there, and then the second stage is there. Then finally the payload separation, the fairing separation happens. the Newton 4 kicks off, which means the upper stage basically. And don't worry, I'll tell you about this LauncherOne rocket and then finally the satellite deployment. So that's how the overall process would look like. So let me just make you see this one. The LauncherOne rocket, right? What is it all about? And then we will have a look at the payload. So this is the LauncherOne rocket. As you can see, this is a two-stage rocket. This is the first stage, Newton 3 engine, runs on Newton 3, and this is a Newton 4 engine. It has a 3-minute runtime. It has a 6-minute runtime, which is like very less as compared to what we have in normal rockets. And this is completed in 2 burns to allow circularization of the desired orbit. If you have played KSP, you know why there are doing 2 burns in here. And both Newton 3 and Newton 4 runs on RP1 and LOX as its fuel. So those are kind of cryofuels, especially liquid oxygen. So there is kind of, you can say, thing for topping off the liquid fuel, but they have done some arrangements for that. When the broadcast is on, you will see those things in action. And the Newton 3 and the Newton 4, as I said, both runs on RP1 and LOX as its fuel. So yeah, this is all about the rocket which you can see in front of you. And this air launch concept is not new. We have the Pegasus launch system also in 90s, if I'm not wrong. But it was not very much, you can say, financially approved because of its high launch cost. But this does not have that problem. So that is a cool thing. Now let's have a look at their the payload. So talking about the payload, they have one payload from the Department of Defense. So since it is from Department of Defense, so we don't know much about it, but only thing which we know is that these Department of Defense satellite will test the integration of space-based communication and in-space navigation in the United States to strengthen the national security. That is the thing. Okay, so the other payload which is flying on this thing is this one. Not this one. This one. The Satrevolution Stock 3. Stock 4 and the Stock 5 actually flew in the previous mission, the Tubular Bells, which was also from the Virgin orbit, and now they are succeeding with the Stock 3 mission. Means the Stock 3 satellite. This is a constellation of the satellite which will observe and collect data from the upper layers of the Earth's surface. It will study the farmland by collecting data on the condition of the crops. And this data can be used by farmers to better the quality and the health of their crops. So if you are a farmer, you know how difficult it is to monitor the health of such a huge farmland. So if you have some assistance from above, then that is always good, and this satellite is going to do that. So one more thing which I want you to know is a very interesting concept which is going to the orbit with this thing is this one. This is a steam jet, small, water powered, sustainable, high thrust engine. Yes, this is a steam jet. That's what they call it, steam jet space system. The main purpose is to have a thruster for small satellites and CubeSats, which is not very what should I say, heavy, which are very small and does not cost a lot. And the solution which they came up with, the steam jet powered thrusters. Isn't it cool? Like a water based thruster. It has nothing but just water, and takes some amount of electricity. That's it. And they have very interesting names also, like the first of all, the steam thruster is high thrust, safe and green, and low power consumption. So ideal for the CubeSats and the small sats. Constellation management, satellite life extension, orbit optimization and maneuver, collision avoidance, and deorbit. So I can sense that as number of satellites are increasing, so CubeSats will have that mandate to have some sort of thrusting ability after their life is over. So in that case, here comes the steam jet, and they literally named it as a tuna can thruster because it is literally of tuna can size and looks like that too. And talking about the impulse, you can see it is 172 seconds, which is not bad considering that it is a thruster and not an engine. So it's like a reaction control system thruster, so you can kind of say that. So it's not bad. And it does not need much of impulse because CubeSats does not require many orbital correction. So yeah, that is the case. And then we have the steam thruster one. This is for some bigger satellites, but a smaller one, like small satellites of 100 kilograms to 200 kilograms. Basically it carries a water tank with it, so carries more fuel, so it is able to sustain for a longer period of burn. So this is a thing which is going on, and I am very excited for this one. So let's see how this thing will come up. And now finally there is one Spire Global payload, which is this one. This is responsible for should I say, this aims to study the microspace debris floating around in low Earth orbit. As you know, the micro meteoroids which float around in Earth orbit, we can't track using the Earth-based system. So we do need some tracking station in orbit to track them, and this is what this Spire Global payload will do. So yeah. So this is all about everything you need to know about this mission, and I will now move on to the stream coverage. I guess that has started. Yes, it has. So let me just do that. A second.
We're so excited to go above the clouds with you today over the course of this live stream, and we have a lot of exciting content over the next few hours. Over to our third co-host, Spencer.
And my name is Spencer Stebbins. I'm an aerodynamicist here at Virgin Orbit. A lot of the work I do
Okay, so there is some problem with the launch.
We're so excited to go above the clouds with you today over the course of this.
Okay, just a second. I guess there is some with their the stream crashed. Exactly, their stream crashed.
Live stream, and we have a lot of exciting content over the next few hours. Over to our third co-host, Spencer.
And my name is Spencer Stebbins. I'm an aerodynamicist here at Virgin Orbit. A lot of the work I do
and their stream actually has crashed. So we'll have to wait, I guess, for some time, or maybe I can find out some other source. Let's just see. Just wait a sec, guys. Their source, their actual stream has crashed, and we are not getting any stream in there. And I can see, is there my thumbnail for this one messed up? Because I can see it has changed for some reason. I don't know. If you can just confirm me for once, it would be great. My thumbnail has messed up or not. And right now we are not getting any stream. Yeah, exactly, not getting any stream from them. Okay, let me just show you how the things are looking like in there. So this is it is looking okay.
It's actually modified
okay, it
the
came
same
back
system in order to actually carry our rocket as well. Beyond that modification, we also did some other simple modifications like removing unnecessary weight, such as the passenger seats that sit on the 747, as well as the bar that actually is on the second floor of the 747. With these two elements, the rocket and Cosmic Girl, we were able to design an air launch system that was unparalleled in mobility and provided a way to create missions with greater flexibility. With that being said, let's take a quick look at our launch timeline so you can know what to expect throughout the rest of today's mission.
Okay, did my stream crashed or their stream crashed? I don't know. My stream was working fine, right? So this is the timeline which you can see in front of you. Let me just do some You can see the major thing is that after takeoff, the Cosmic Girl do its maneuver of dropping off after T minus 58 minutes. So there's almost like a 1 hour thing which you can see say of after takeoff and before dropping off the stage. So that is the case. And then the stage separation happens at D plus 187 seconds. And yeah, that is the thing. The PST ignition is nothing but the settling thrusters ignition at D plus 3.2 seconds. And then finally the first stage engine ignites. So this is how the things look like. It wasn't mine, yeah? So okay, thanks. Yeah, what about my thumbnail? Is it all good? It's not good, I guess. I don't know, for some reason it is not looking good. Just a sec. That should not have happened. I think some YouTube glitch or something like that. Let me just update it.
Expected warnings.
Just a sec. I don't know. I could see something was messed up there. So okay, back to business.
Clearing flight software warning.
Okay, so the takeoff time is there in front of you, 1:23 p.m. Pacific time, and the thing which you are seeing in on your screen, that my timer is for the drop off time. You can say it like that. So we 1 hour 21 minutes before everything happened. It drop time 1 hour 21 minutes. So I need to update my timer. But okay, let me just tell you what is going on in the screen. First of all, there are some views. The LauncherOne is on the pad. Many people are there, inspecting everything. So in the thing, the Virgin orbit where is written on the LauncherOne, that is the PST, which is the settling thruster. So that is one thing to note in this scene. And right now the team is doing all the checks, talking about every whether the fuel is correct or not, uh, all the last minute checks for the rocket as well as for the aircraft. Yes, aircraft also needs to be checked in here. And the plane, the Boeing 747 here, is modified, and all the seats inside is taken off to save the weight, obviously. And the reason why this plane was chosen for this thing, because this plane already had one place to have one extra engine on its one wing. So it was actually designed to have okay.
Stand by for SMA.
Okay, so the mission control says we are going in for a good takeoff time. So let's hope that is the case. And yeah, I was talking about why this was chosen. So this plane was basically designed to have uneven weights on both of the wings. It was designed to carry one spare engine on one of the sides. So yeah, that's why it was chosen.
Air and Spaceport in Mojave, California. Mojave Air and Spaceport originally opened as the Mojave Airport in 1935 and was granted its spaceport license through the Federal Aviation Administration in 2004, becoming the first private airport in the U.S. with a commercial spaceflight license.
So what you're actually seeing through some of these shots, especially this one, is a large wind turbine farm in the background. Fun fact about Mojave, it's actually home to the third largest onshore wind energy project in the world.
And if you're based in the LA area and plan on going skiing or snowboarding anytime soon up at Mammoth Mountain, you will drive right past the Mojave Air and Spaceport on the 14 freeway. And if you're lucky, you may even get a chance to see Cosmic Girl.
Yeah, and let me add this. Mojave has a rich history in aerospace flight testing and space industry development, but since it's located in the Mojave Desert, The only thing you'll find more dangerous than the rocket engine testing are the creatures that live there. The black widow spider, the tarantula hawk wasp, and the Mojave green rattlesnake, very poisonous, all call Mojave home. So watch your step.
I've actually seen a black widow in person, and those things are so tiny. It's impressive that they can pack such a horrible bite to them.
Absolutely.
Well, one more fun fact for you guys. This was actually where the VSS Unity of our sister company, Virgin Galactic, reached suborbital spaceflight for the very first time back in 2018.
Virgin Orbit and Virgin Galactic are separate but sister companies with a shared founder, Sir Richard Branson. Virgin Galactic is opening space for everyone by enabling affordable suborbital human spaceflight so that anyone can become an astronaut. I know I'd love to fly to space one day. But Virgin Orbit is opening space for everyone by enabling affordable, anytime, anywhere orbital access for small satellites that bring positive change to all of us back here on Earth.
So to help everyone at home differentiate between Virgin Orbit and Virgin Galactic, let's take a quick look at our launch simulation that we've put together for you.
Okay, so I guess that would be interesting. So right now, okay, yeah, settling thruster, the first stage engine, which is the Newton 3 engines, fires up and it takes it above the atmosphere and into the vacuum. And once it is there, it separates, and yeah, that is not collected. It just drops down in the ocean. And the second stage then completes its mission. The fairing separation happens and the payload separates pretty, what should I say, common profile, rocket profile, right? Except for the air launch part. Okay, so let me just answer some of your questions. Can we put a crew capsule shuttle on Virgin Orbit? Cheap international space station travel. How about Boeing X-37B space plane or Sierra Nevada Dream? Okay, so this is a thing which is actually going on. Talking about SST or something like that. Like X-37B is a military shuttle or drone kind of a thing, which you can say, which actually goes into orbit. Okay, and this is their rewind. Which means their tubular bells mission, which happened last year, and that was successful.
So everything from making sure the plane is ready, the ground support equipment and the rocket are all ready to go, as well as the people on console and all of our procedures and operations are ready to support a successful launch.
The launch engineers on launch day, we're at L-0 day, it's our big game day. We first go out before rocket loading and we do our pre-flight checkouts just to make sure everything is good to go before we load cryogenics onto the vehicle.
For last launch, I came in after fuel load, and I sit on console to monitor the system during engine bleed and TVC bleed.
I'm really focused on the risk of our program, so any kind of technical or program risk that we have, and then if something comes up at the last minute, really working with those teams to disposition that and address it as quickly as possible.
It's amazing to be part of the launch operation team because it's kind of a testimony of like how hard the entire company works together, from manufacturing to integration to all the engineering support.
As soon as you release the rocket, I think it's honestly is when it hits you, because during the time of terminal count and all the way leading up to it, you're pretty laser focused. Really, it's not until after the release of the rocket that you really take all those emotions in.
There was a lot of intimidation walking into an incredibly successful company that was really ambitious with their goals, and to see that we had so much representation on our first operational launch was really, really special to be a part of, because I think it's the next step forward as the industry kind of recognizes the value of diversity in their workplace, but also being now at 50% representation, it's really great to not be the only woman in the room.
I think as a company, there's definitely room to grow and room for improvement and get the company at more of that 50-50 sort of level, but it is amazing to see so many females doing so many amazing things.
That's great to have a female presence always in a company, right? Okay, so yeah, I was answering that your cheap international space station travel. Well, that could happen only if we have an SSTO in function. So that is actually in development, but
Is moving towards the runway.
okay, let's have a
She
look
should
at
be
that.
wheels up in no time. I'm pretty pumped. What about you guys?
Oh, I'm so excited. Oh, you can see such a beautiful shot of her right there as she's moving down the tarmac. such a beautiful day in Mojave right now. Especially you can see the size of Cosmic Girl on the rocket underneath wing. It's such an impressive sight.
Yeah, now LauncherOne is 70 feet long, and when you're up next to LauncherOne, fully integrated in the factory, she looks to be a fairly large rocket, but under the wing there of a Boeing 747-400, this massive two-story commercial jetliner, LauncherOne looks small indeed. But what an exciting moment here as we get ready for this distinguishing feature of air launch, the takeoff of the carrier aircraft from the runway.
And actually, that's one of my favorite things about working at Virgin Orbit. I work above the manufacturing shop floor, and we have like a nice window overseeing the whole flooring. So you can see pieces of the rocket as it comes together, and so you can see the size of it, and it's absolutely breathtaking. But when you see the whole thing put together, it's even more so amazing. I can't wait to see this baby launch today.
So right now, I have updated my timer to match the takeoff. Hopefully that will happen. So right now you can see things are going smoothly here. We are T-minus 5 minutes until the takeoff happens, and then I'll update it until the drop-off time. So do you have killer spiders in India? No. Spiders here are not at all dangerous. They are like very, very small, very small. The thing which are scary here is, you can say, monkeys. Monkeys are all over here. So that is one thing. Okay. Yeah. So let's just take some questions if I can, or maybe just enjoy the launch. Take off right now. The Cosmic Girl is getting ready, and I hope I can't play this music right now, but yeah. Okay, let me answer some of your questions. So yeah, answering that, we need an SSTO for that cheap travel to being possible, and SSTOs are very, very difficult to make because of their size, and the difficulty is in their fuel efficiency. If we can have a nuclear rocket, then SSTOs are there and the logical step to happen. But since we don't have that, so therefore we have like minimum 2 stages in a rocket, one for atmospheric and one for vacuum. So what's the launch window? Launch window for this one is kinda, what should I say? It actually does not depend much on the launch window, because it is actually launching from air, and it can actually adjust the plane can actually adjust the things according to the requirements. So if there is any delay or in the launch, the plane can actually compensate that. The only thing which actually factors in is the FAA allowance for it, for this that clear air space. So the launch window is 2 hours and 30 minutes for that. Weather is not an issue for air launch system. Yes, because this is a plane is actually launching it, and if there is any problem with the weather in the area, the plane can actually just move out of that area and launch from somewhere else. So it's very simple and very advantageous. So weather is not a concern for this. Wherever if a plane can handle that weather, the rocket can also, because it will be actually dropping this rocket at around 35,000 feet. So at 35,000 feet, you can kind of say most of the thick atmosphere is out of the way. So you can say it is above the clouds. So weather is not much of a concern at that point of time. For the music, actually, the thing which I was playing, the music which I was playing, that is copyright free. But right now, thing which is playing in the actual stream, that is copyright. That will give me a copyright. So yeah, that's why I have silenced it. So we are T-minus 1 minute and 30 seconds, hopefully, from the launch of this takeoff of this basically airplane. We'll have to wait. See wildflower with 172 seconds of potential. No, that's a ISP basically, potential ISP you meant to say. For CubeSats, you actually don't require much of adjustment. Normally, you are actually okay with nothing, but if you need to extend the lifetime, then you need to have some launch system, the thrust basically, the engine, some kind of thruster. So it can actually, the tuna can thruster for the steam jet can actually take the variations from plus minus 70 kilometers. So it has that error. If the perigee drops like 70 kilometers below, it can raise the periapsis to attain more life, or maybe do some collision avoidance maneuver. So CubeSats normally don't require any sort of propulsion system. So yeah, that is the case. So you can go away with small efficiency engine. Okay, so why airport? Because this airport, the plane which you are actually seeing in front of you, okay, so it should have taken off. For some reason it's not. So we are actually having some delay in the takeoff. We have to wait for some time now. You will see the action. It is actually, the takeoff is also very breathtaking. I have actually experienced that in previously in the stream, so that would be worth the wait. So don't worry, the takeoff is kind of very breathtaking itself. Oh, hi Louis Smith, how are you? I'm fine here. Okay.
Discussion with flight software. It was a blip. There's nothing in the error logs, and it was not seen on the plane.
Copy.
Okay, so they actually had some last minute glitch, as the mission control said. So right now there was some kind of error which they said, and now they checked it. Everything looks fine. That's what I heard. So hopefully you will see the takeoff soon now. So talking about the airport, yes, it is on the airport because this is a Boeing 747 and this is an airplane. But there is one anomaly in the wing which you can see. If you can see in the right wing, there is some sort of white circle kind of a thing, and that anomaly is nothing but a rocket. Okay, so this is a air launch rocket. So this is kind of, you can say, the launch pad for this rocket is an airplane, and therefore this launch pad can go anywhere in the world and launch from anywhere, wherever you want. So therefore it can attain any inclination without even wasting a single drop of rocket fuel. How cool is that? The air launch system always made sense to me, but because of the weight limitations it is not considered much. But hopefully we will get to see some more air launch businesses coming in after this thing becomes viable like this one. Okay, so again the stream lagged, I guess. Not from my side. So we do have to, I don't know. Okay, let me just give you some update regarding if it'll take off time. That's like, it's already 125, right?
I'm fine.
Oh yes, this screen is kind of futuristic and takes me back to The Expanse, if you have seen that. Okay, the series finale is coming up tomorrow. Uh, excited. Not tomorrow, in just few hours. Okay, let's get back to this one. The stage one consists. This is a UI kind of a thing which has like fuel 100%. You can see the oxygen 100%, and the second stage also. And for the stage, this is the thing which I love to see, the all the readings and layouts. We have the helium pressure. You can actually read everything. Then fuel temperature, the oxygen temperature, interstage temperature also is there. The payload temperature is there, and the stage 2 as well as helium temperature and how much is left in. So stage 1 is having around 25.6 volts. Stage 2 is 20.16 volts. Okay. Altitude is already 2574. Pylon thruster. Pressure in the pylon thrusters are okay. No, not the pylon thrusters. Those are the pylons which are actually holding that rocket in. So it's a cool layout to have, right? Okay, so moving on to other questions. Have any team thing? A couple questions. Are they using any anti-freeze chemical or something else to prevent freezing and reheating? Actually, that's a good question. But okay, let me just tell you that they are taking water as their fuel, right? But they also consume like 20 watts of electrical energy, so maybe they are heating it before they basically, you can kind of say like before they turn on the engine. The engine turning on must not be instant, right? They must be like they need to warm up the engine and then turn it on, maybe. um, Maybe not. Or is there any sophisticated system for heat transfer or something like that? The details are not yet known right now. But the most logical step for a small system, which I think, is that warming up the iced water and then using it to do this all sort of things. And warming up is always easy. You have the electricity in space which you can use, so we'll have to wait. uh we still are at a hold right now, and the expected drop off time is also not getting updated, but it will get updated. So there's a thing which we need to look. Maybe I need to launch or take off imminent, I should say that. Just a second. Okay, guys, if you are new to this stream or new to this channel, let me just tell you that on this channel we do live streams of all the rocket launches, as well as some sciencey stuff if it is, or spacey stuff, if any is happening, any science, some cool sciencey thing. Maybe JWST when it is giving its first images. If there is any live stream of that, you will get those things in this channel only. So this is a channel where you get all the live streams as much as possible from every rocket launch provider in the world, even for the Chinese ones, which are very, very hard to find. I need to dig up from my sources, and yeah, that's how I provide you the live stream from China. So this is a channel where you can find all the live stream, as well as you actually get to know about what is happening on the screen. Okay, I like to actually explain you each and everything that you will be seeing on the screen. So for this launch, if you want to know about this launch fully, you can just rewind this stream a little back in during the starting of the stream, and there I have explained each and everything you need to know. And this is a tempo which I follow for every live stream. Also, we have many space related videos not many right now, but hopefully many will come now. So one is in the making. I should be releasing by the month end, hopefully. So let's hope that happens. And if you want to support me, you can actually become a member of this channel. That really helps me. And uh, talking about members, shout out to all the members and the Patreons that have supported me for this journey, and it has really been good right till now. And shout out to Mohammed Wheel, if I pronounce it all right, Mohammed Will, for becoming a astronaut tier member on this. Thank you so much for, if you are watching, Mohammed, thank you so much for your uh, appreciation. Really appreciate it, man. Now I can actually have some stable income coming in from this channel, do some more things about it. So if you want to support me, you can do that by becoming a Patreon or the member. Okay, now let's get into the stream. If you have any questions, you can just type in there and I will try to answer as much as possible. Uh, how are you? I'm looking forward to this launch. I am great, and hopefully we all are looking.
As you can see, Cosmic Girl and LauncherOne are still on the ground. We're taking this time to go through some final checks of subsystem performance and verification of system health. So stay tuned, stand by. We'll provide an updated takeoff time as soon as we have it.
Soon. Thank you so much. Okay, so they are looking in for some last minute glitch, as they say, right? So is a thing. Oh, thank you so much, Jan Vam, for that 20 sec or it pronounced Swedish currency, if I'm not wrong. Thank you so much for that. Really appreciate it, man. It really helps this channel to be functional. And obviously this laptop thing which happened today, I have to get a good laptop for streaming and improving overall quality, so every bit will help. Was Virgin Galactic grounded due to some problems with the crazy plane they used? It was yes, Virgin Galactic, yes, it was Virgin Galactic only, not Virgin Orbit. Virgin Orbit is doing good. Virgin Galactic kind of was grounded, not from a crazy plane. Actually what happened was they kind of went outside their airspace, I must say. So that's what actually caused some problems for that, but now everything is good. So they have improved their systems also for that. So at the end of the day, it was a safe flight and no one was even scratched. So I think that's all good. Hi Mark, how are you? Good morning to you. Good day. Okay, not good morning. Here it's not good morning at all. Is there a specific reason for the fuel oxygen setup? Okay, that's a good question actually. The RP1 and LOX is a industrial standard kind of, you can say, is a semi-cryo fuels which people operate. But I must say that for this launch, for air launch, since you don't have this, luxury of topping off the rocket fuel, so I initially thought that they would have gone with the N2H4 and those UDMH fuel, which is like hypergolic fuels, which does not require any igniter, and they are earth storable, which means they are not cryo fuels. I thought they will be using those fuels, but no, instead they went with cryo fuels in it. And oxygen is a cryo fuel. RP1 is still kind of, you can say, not very cryogenic, but here we have the plane has started, which you can see plane has started moving. So the takeoff is imminent now. Finally, I'll answer to that question, but right now let's just enjoy this beautiful takeoff which is going to happen now. And let me just tell you, it will be breathtaking. Just enjoy it. Hopefully we will get some what should I say, that Right now, just the music is playing. Hopefully, we will get some natural sounds. That would be great. Cosmic Girl is ready. Support the LauncherOne, which is hidden inside one of her wing, and hopefully she will protect it uh, till the time it drops. So the thing is looking great right now. Finally, Cosmic Girl is on its way, carrying the LauncherOne rocket to its intended location and then finally dropping it off. So let's get this party started. See, Kisa Riley, as you said, can we listen to the Virgin Orbit operators? Right now, nobody is speaking, and whenever someone speaks, I make sure you also listen. So don't worry about that. Right now, just the music is playing, so you don't have to worry about that. This is okay.
Taxiing towards the runway. Her engines are all warmed up and ready to go, so we should be wheels up in no time.
Yeah, again, very, very exciting. You can see the 70-foot-long LauncherOne rocket safely nestled under the left wing there of Cosmic Girl, the Boeing 747 carrier aircraft. We're just moments away from one of the early stages of air launch, which is the takeoff of the aircraft from the runway, to begin our transit time of about an hour over to our Pacific Ocean drop point, at which point we will release LauncherOne to begin powered flight to orbit.
I think now it is coming to full power. Not the music again, please. Let's just enjoy the natural aircraft noises. Whoa, she looks beautiful, isn't it? Okay. Cosmic Girl is ready to go. Mojave Desert is actually kind of very beautiful. Right now the plane is taxiing in onto the runway before getting onto the final, what should I say, final pad, final run, whatever that is called. Okay, guys, there you have it. It is speeding up, and we have the noises. Cosmic Girl speeding up, and we have takeoff. There she goes. Whoa, okay. That was indeed cool. Cosmic Girl is on her way to take the LauncherOne to its desired location. Taking kind of a U-turn right now to go to the Pacific Ocean. That's where it is going right now to drop off the launcher. So yes, finally the plane has taken off, and now I can actually uh, change my drop off time. 46. That. Okay, so there she goes. Cosmic Girl is above the ground. Everything is nominal, and now we are just waiting for the drop off to happen in 46 minutes or so.
We have a successful takeoff of Cosmic Girl and LauncherOne from the runway at the Mojave Air and Spaceport in Mojave, California. Looks like Cosmic Girl is on her way to going above the clouds.
I know. That was an absolutely gorgeous view of Cosmic Girl as she was taking off with the Eastern Sierras in the background. A fun fact about the design for the rocket, one of the things we had to consider from an aerodynamic standpoint was making sure that the rocket didn't have too large of tail fins so they wouldn't strike the tarmac as Cosmic Girl was taking off. So we had to do a little design right there to get it just right.
And as a reminder, Cosmic Girl will be flying out to the Pacific Ocean to the drop point, which is about 50 miles south of the Channel Islands.
Okay, so now we can actually resume our question answer session. So yeah, so what I was talking about, why is there a oxygen setup? Okay, so see, again, the cryofuels, if you use cryofuels or semi-cryofuels as in this case, then you can actually reduce the size of your rocket because those are efficient fuels in there. So right now Cosmic Girl is doing good. I can't just, it's like airplane travel is still is very common nowadays, but still airplane is a thing which you, whenever it passes above you, you kind of look above the, you know above you, basically towards the sky, to spot any helicopter or anything going above you. So that's what I do. Okay, coming back to your question. So the thing is that since these are cryogenic fuels, so you can actually have more fuels. If you have decrease the temperature, you can have more fuel in the same volume, and therefore you can actually achieve higher burn time and finally more delta V basically. So therefore size was main concern here, because this is a air launch vehicle, and you don't want to have a very large size of that rocket. So that's why they went on with semi cryo rather than those UDMH and N2O4 fuels. Is there a specific reason for the fuel oxygen setup? Why the fuel fuel at the tail and oxygen at the middle? Well, that's a good question actually, and there is a specific reason for that. The weight of the fuel is actually basically the density of the fuel, or you can say the molecular weight of the fuel is not the density, but I should say the molecular weight of the fuel is heavier than the oxygen, right? If you have the molecular formula and you find out the molecular weight of the fuel, that is heavier. So basically the fuel is heavier than oxygen and liquid oxygen, so therefore it is kept in the bottom side, because you want to have your rocket to be bottom heavy and not top heavy. Once if you have the rocket as top heavy, then that means you are calling your doomsday. If you have played KSP, you know what I mean. So most of the time, indeed, every time you ensure that your rocket is bottom heavy, and for that you need to have as much heavy things beneath the rocket. So that's why the fuel is below and the oxygen is above, because the fuel is heavier. Okay. So this is the rocket cam, or you can say the pylon cam, whatever you want. This is a rocket cam, I would say. This is a rocket cam, which you will see, or you can say the onboard camera, which you will see when the rocket is actually dropped off also. The rocket is horizontal, how can it be bottom heavy? Uh, that is actually a thing which we say because the horizontal bottom heavy. What do we mean by bottom heavy? Which we actually mean that most of the weight is toward the tail section. That's what I meant to be, the bottom heavy kind of a thing. Because when it is horizontal, also if it is top heavy, then it will dip below, right? You can imagine that when it is moving in horizontal direction, and if it is top heavy, then that will cause the rocket to dip below. But if the rocket is bottom heavy, or you can say tail heavy, then the rocket will not dip below but come above or up from that. So that's why you actually have those things. It ensures more stability during the flight. One of the reason is that the top heavy will tend to go downwards, and the bottom heavy will actually tend to go upwards. So that is the main reason, or you can say the main philosophy of all the rocket designs. So right now everything is looking great. We still have as we move forward, we are getting some changes in the drop off time. So we are D minus, not T, sorry, D minus 42 minutes until this thing is dropped and we get to see the thing. So right now it is around 440 kilometers and are 8,000
And now
feet.
joining us is a very special guest, the founder of the Virgin Group, the man, the myth, the legend himself, Sir Richard Branson.
Yeah.
Hi, nice to talk to you.
Nice seeing you today, Richard. So you were in Mojave for our last launch, Tubular Bells Part 1. How are you feeling after just watching Cosmic Girl take off?
Obviously, just like all of you, excited, always slightly nervous at this stage. You can never be sure in these early flights whether every mission is going to be successful. But just at the edge of my seat, like you and the rest of them, and it's incredible what the whole team have accomplished. I can't remember whether this is our third flight or fourth flight, but anyway, it's always incredible to be watching, and a great privilege.
Now, Sir Richard, the beauty of flexible small launch is that we can service a diverse array of customers on the same flight. On this one, we have U.S. government, U.S. commercial, and international customer payloads. What do you find most exciting about that?
Oh, look, I think that for people who question space exploration, they don't realize just how much it offers to mankind back here on Earth. I mean, one of our satellites that is going up today will be monitoring agriculture and crops around the world and so on. And it is that wonderful diversity of different organizations and different companies that have got brilliant ideas to try to use space to better things back here on Earth. And I think we've got something like 20 other customers waiting in the wings after this to put their projects up, and I'm sure there'll be many more after that.
Absolutely.
So let's talk about the future of Virgin Orbit, actually. I know we have a number of launches coming up. Which one are you most excited about?
I think that I was just looking at the 747 and having a little bit of a trip down memory lane. And this plane was I think the second plane into Virgin Atlantic's fleet, something like 38 years ago. I wasn't sure that Virgin Atlantic would survive more than a year or two, and I don't think anybody were in those days. We were taking on British Airways with 300 planes, and we had a couple of planes. I certainly was not sure that, or never dreamt that one day it would be taking off from Mojave with a giant rocket on its side, and putting satellites up into different places in space. And the tremendous thing about using a 747 is we can put them into any orbit from anywhere in the world. So it's definitely a pinch me moment. I mean, this goes right back to when I one day saw one of our 747s taking off with 3 engines on one side and 2 engines on the other, and we just suddenly thought, well, if you can get 3 engines on one side of a 747, maybe we could put a rocket on it. The reason for 3 engines on one side and 2 engines on the other was, if there's a technical problem in Alaska, you have to send one of your other 747s to bring a spare engine. The only way you're going to get it there is to put it on the wing. As to the future, I mean, I'm obviously excited about every single rocket launch and all the different things that all the satellites inside those rockets can do. I mean, there are so many urgent things that need doing back here on Earth, whether it's monitoring the rainforests, maybe places like Norway who are doing deals with places like Brazil to ask them to not to cut down the rainforests, and then rewarding countries for not cutting down rainforests. The only way you can properly check on it is really via satellite. I mean, you can do a certain amount on the ground, but to completely verify it on a month-by-month basis, you need to do it from the air. So it's projects like that. I mean, in the Virgin Islands, right here, we have illegal, fishing boats coming through. Again, it needs satellites to be able to alert the authorities that trawlers are coming through with massive nets and long lines and pillaging the seas that belong to the British Virgin Islanders. And that's the kind of role that Virgin Orbit can play. And Virgin Orbit is unique in the world. I mean, the fact that we can actually, there's only, I think, a couple of handfuls of countries that have the capability of sending satellites to space from their own countries. And now all 180 countries can use Virgin Orbit. They just need to ring us up. We can send a 747 and operate out of their own country and launch satellites for the first time. The UK is one good example. I mean, later this year we should be launching from Cornwall. The UK's never put up its own satellites. Now, I think this year there will be two flights from the UK, putting satellites up from the UK, and there are many other countries that have expressed similar interests.
And one last question for you, Richard. So as you may know, we have many international viewers watching from around the globe, but in particular, we have a small number here in California, namely our Virgin Orbit employees, that are primarily watching from home with their families due to the coronavirus pandemic. Is there anything in particular that you'd like to say to them?
Well, first of all, to say, thank you for all you've achieved. Obviously, we hope for a successful flight, and if it's not successful, we'll be back putting up another rocket. I'm sure, knowing the lot of you within a month or two, but I'm sure it's going to be a success. To wish everybody well. I mean, our family and friends all got COVID over Christmas, and fortunately we were vaccinated and boosted, and therefore none of us got it badly. I mean, my wife, who's a bit older than me, hardly knew she'd had it. So So if you can, get yourself vaccinated, get yourself boosted, get yourself protected, you can then, I think, ride this particular Omicron variant, and be around to watch, many more flights, but basically just say thanks very much. I mean, you've achieved something extraordinary. And I know that you'll have lots more extraordinary things to achieve in the years to come.
Well, thank you very, very much for joining us, Richard, and we hope to see you back shortly.
Thank you very much. Cheers. Good luck in the next hour.
Thank you.
Cheers.
Okay, so that was some words from Sir Richard Branson. Always will say. So right now everything is looking good. So let me just see if we have any other update. Tell you we are going as per the plan. So put in front of me. Okay, so everything is good. We have no updates yet, so everything is as per the plan. And here you can see, we can see the flights. We are moving at around 436. As per our height is, altitude is around 20,000. That's the cruising altitude for the airplane. Once it is near the location, it do certain sort of maneuvers to actually move up to 35,000 feet or even above that if it is possible. And um, um, during the drop off maneuver, it will incline itself at an angle of 27 degrees so that it can have like that inclination. The rocket can have that inclination during the drop off, and because of that inclination, when the engine will start, it will start to the rocket will start to go up and nowhere else. That's why that inclination is. So these are the parameters which we actually see. Everything is looking good. Temperatures and the pressures, everything great. Should be right. Okay, so okay. This is the flight tracking which is in front of 45 minutes. Okay. The time is actually changing again and again. Again went down to 45 minutes now. Date my time.
Joining us live in the studio here in Long Beach, California is a special guest, Colonel Carlos Quinones, Director of the U.S. Department of Defense's Space Test Program, or STP for short. Colonel, thank you so much for being with us today and for taking the time away from your mission team to join us on air.
Absolutely. It's great to be back, Paul. I appreciate it. Great day today. Another opportunity for us to put additional capability into space, to continue to push the envelope and actually take care of business so we can get the warfighter the tools that they need.
Excellent. So tell us more about DoD Space Test Program, who you are and what you accomplish.
Absolutely. So the Space Test Program has been around for a long time, over 54 years. And the job of our job is to demonstrate technologies, upcoming technologies, to accelerate development of war-winning capabilities for the joint warfighter. Our job is we do this by taking those technologies, do the mission design, the vehicle procurement, we do the integration, launch, and operations, and then take and analyze those capabilities, those technologies, and see which ones are ready to go to the next level. And the next level means for operations and to support of the activities and the missions that the Space Force needs to do. And this is critical because the SpaceX program is helping the Space Force, the Department of Defense, Space Systems Command to go after the threat and make sure that we stay relevant and the equipment is ready to do the mission and support our brothers in arms.
Excellent. Now, this mission is part of the Rapid Agile Launch Initiative, or the Raleigh project. Could you tell us a little bit more about the goals of that project specifically?
Yeah, absolutely. So the Raleigh, which is the Rapid Agile Launch Initiative, is one of those, it was a congressional initiative, and it was meant to help a venture class launch, small launch providers with using commercial practices to come and be able to support the mission of the Department of Defense. And the idea of those activities to be able to leverage new technologies, new processes, new equipment, and see if we can actually leverage and have a more resilient capability associated with the launch enterprise. And why is that important? Well, it's important because we need that to do our space mission. We at STP, in conjunction with our brothers on the launch enterprise side, as part of Space Systems Command, are trying to push that technology forward, have a more resilient capability, so when we need it, it's there for us to deliver the capabilities that our leadership needs in space.
So there are 4 STP-sponsored payloads on the Above the Clouds manifest. How are those payloads selected by your organization?
So all the space technologies that STP flies are going through what we call the Space Experiments Review Board. And it's a DoD-wide activity where all the different agencies and services bring their upcoming technologies and the demonstrations that they need, and then they get rack and stack. And then once that gets approved by headquarters at Space Force, then we take those and then we execute to those. So once STP gets that list, then we work through our process, like I talked about, mission design or space acquisition or spacecraft acquisition. And then we go through that process and then we manifest, and that's how we got into this specific mission.
Excellent. So Cosmic Girl just took off. She and LauncherOne are on their way to the drop point. It's going to get very exciting here soon. You know, in your view, what capability does this bring to the Space Force, the Department of Defense, and your mission partners?
Yeah, I think when it comes to mind is flexibility. We always looking for flexibility because we need to be able to act and be able to provide the technology not only that works, but also in a timely manner. And the concept that Vox has, where deploying from an aircraft, allowing that flexibility, because now you're not specifically attached to a specific ground point and the challenges that can come with that. So I think we're excited about seeing where this technology goes and the opportunity of that. This is our second launch with Vox. We did VP Alpha, and that went very well. We're looking forward to another successful mission, another opportunity to actually showcase not only the technologies that we have on board this specific capability or the specific mission, but also to showcase the ability of Vox to do their mission.
Well, thank you so much, Colonel, for coming on the program here today. That is Colonel Carlos Quiñones, Director of the U.S. Department of Defense's Space Test Program, demonstrating emerging technologies in space to accelerate the development of space capabilities for the warfighter. Stay tuned for more exciting content. We're getting closer and closer to LauncherOne's drop time. Stick with us. We'll be back soon.
Okay, so things are looking good in here. The onboard camera is great, and just witness or the director there, everything is good. Okay, let me We're good now. Okay, so so guys, if you have any thing to ask, you can surely ask me. Try to answer. So yes, this is the flight map which you can of you. Mojave Cosmical takes off. This is okay. This is messing up. But you will see.
Signal good tracking on all 3 ground stations right now.
Copy. No good tracking. I like it.
Okay, so we are still green for the launch right now. That's great.
30,000 feet, we remain in cloud.
Okay.
Copy is 30,000 feet, still in clouds.
So they, kind of do this circle kind of a thing when they reach their point. And right now they are at like 30,000 feet. And this is, as they say, the racetrack hot past, because they do this circle kind of a thing. And then finally, after dropping off, the cosmic gull obviously comes back, and then the rocket goes to its desired orbit. That's how the things work in here.
Cosmic Girl Orbit Base on the S-turn maneuver. What we're really looking for is 30 to 45 degrees of heading change in 2 different directions. It's your standard INS realignment kind of maneuver.
Okay, so these are pilot for today, which you can see.
We haven't been briefed on an S-turn maneuver.
Say that again.
You actually can
To address the GNC converge LCC, we're currently not passing. I believe the IMU is not currently aligned, so we're looking to do that maneuver that we're describing.
Okay.
Okay, that's copied. And can you repeat the maneuver?
Yeah, Cosmic Girl Orbit Base. What we're looking for is 2 different heading changes, about 30 degrees to 45 degrees each direction. You probably won't be able to do that until you get into the Altrav airspace.
Yeah, that's copied. We'll try and do that as early as we can to get an early call on.
Copy all, thanks.
Santa Barbara, see, this rocket is very tiny, and to spot an airplane going above Pacific Ocean would be a difficult task. So good luck for that.
For the STP-27VP Bravo mission conducted under the Space Test Program's Rapid Agile Launch Initiative, or RALI. The RALI project was initiated in response to congressional guidance to procure prototype commercial small launch services capable of taking research and development payloads into low Earth orbit. Above the Clouds will launch 4 STP-sponsored payloads to demonstrate flexible, responsive, non-traditional launch capability for the U.S. Department of Defense. Let's take a closer look at these payloads. The Pathfinder for Autonomous Navigation, or PAN experiment, demonstrates a low-cost, adaptable autonomous rendezvous and docking solution using 2 3U CubeSats designed with modular subsystem functionality. Technology Education Satellite 13, or TESS-13, is a 3U CubeSat experiment sponsored by the NASA Ames Research Center, exploring novel capabilities including nanosatellite class machine learning, exobraking for rapid deorbit, and advanced communications. The Global Star Evaluation and Risk Reduction Satellite, or GEARS-3, is a 3U CubeSat sponsored by the Air Force Research Laboratory to explore how a prototype patch placed on the exterior can provide details on spacecraft health via commercial satellite network connectivity. And in addition to these 4 STP-sponsored payloads, the Above the Clouds manifest also includes 3 commercial rideshare satellites. Polish new space company Satrevolution is flying their Stork 3 and SteamSat 2 satellites. Stork 3 joins the Stork 4 and Stork 5 MARTA satellites placed in orbit by LauncherOne on our 2021 Tubular Bells Part 1 mission as part of Satrevolution's Earth observation capabilities with a focus on customers in the agricultural sector. SteamSat 2 is a technology demonstration for Steamjet Space System UK's innovative water-field thrusters for in-space propulsion. And finally, as a late call-up addition to the Above the Clouds manifest, from final approval to full integration in less than 24 hours, is Spire Global's LauncherOne satellite. This 3U CubeSat mission is the first privately organized satellite of Austria, tackling the challenge of micro-space debris, small particles with high velocities that can pose a serious danger to orbiting satellites. A partnership between the Austrian Space Forum, Findus Venture, and Spire, LauncherOne focuses on detecting nearby objects too small to detect from the ground. This nanosatellite detects space debris via a radar and using a piezoacoustic sensor that vibrates on impact, literally a microphone in space. Findus Venture is financing the mission, and the Austrian Space Forum is a space research organization with more than 250 volunteers from 20 countries. To these 7 payload teams, welcome aboard LauncherOne, and we wish you 100% mission success as you go above the clouds to use your technologies for the benefit of all of us back here on Earth. Now, let's hear more about the TESS-13 satellite in particular and the amazing team behind this satellite. Go ahead and roll the video.
Hey.
This is TechSat number 13, and this is our second flight on Virgin orbit, which we're very happy to be part of. And this particular mission is a 3U nanosatellite, and it's full of rather interesting and innovative experiments. We're very cognizant of orbital debris, and so by having a drag device that is simple and reliable, it means that we can bring our nanosatellites down and dispose of them a lot faster, not having them as a potential debris for other satellites or human vehicles to run into.
And I'm really happy to be part of the ExoBreak team, so I was involved in the design and the building phase of the subsystem. So we are a small team, and I really want to acknowledge one of our colleagues, and I call him like the hero of TechSat. He's really quiet, really discreet. His name is Alejandro Salas, and he's our lead ops engineer.
This will be the first of a series of flights that will begin to expand on machine learning in space.
Today we got a chance to go in the clean room, do the final voltage testing, and then with the help of the Virgin Orbit team, we were able to integrate the satellite into the flight dispenser. Today was a really smooth process that my team and I hope Virgin Orbit team also enjoyed.
We command and control satellites through email, which is very unique, and we pioneered that some years ago, and it works to a great extent. We got injected into a perfect orbit, and that was a year ago, and then 9 months later, the satellite still sends lots of valuable data, so it's up there. The timing will be such that we'll have 2 satellites in orbit at the same time, thanks to Virgin Orbit.
I think TechSat it's really important from the NASA standpoint, but also for the entire space community. TechSat Group gives an opportunity to entry-level engineer to really be part of a space mission, and I think you change the entire space ecosystem because you get a chance to fly your own payload. When I was doing my master's degree at San Jose State University, I was already part of the TechSat team, and that's where I started working on the ExoBreak. So over the past years, I was able to work on 3 ExoBreaks. To be the first female customer, first of all, I was surprised because I was greeted here by 3 or 4 women, right, at Virgin Orbit. So I felt like home. They were all the personnel here. It's really, really nice, and they make sure We have everything to complete the integration.
We're just happy to be here again, and we look forward to 2 more flights in the next calendar year.
Thank you. Thank you to my team. Thank you to Virgin Orbit, because I also think that it's a great collaborative effort. And during this challenging year, we were able to work together, put a satellite together, and today integrate. So we are all, cheering for Virgin Orbit right now and hoping for the best.
Okay, so we are looking good, and a D minus 28 minutes, and that was a quick little video for one of the payloads which is going
For those
today.
watching a live stream today, what you've most likely seen in the background is a number of graphical user interfaces, or GUIs. Now, these GUIs are composed of some of the parameters our launch team across Virgin and Orbit are monitoring to make sure they keep track of the health and status of both Cosmic Girl and the rocket. Let's go ahead and take a look at one of those GUIs. These GUIs will show captive carry, stage 1 ascent, and stage 2 ascent. The current GUI that we have on the screen right now is for captive carry. To give you a little breakdown of what you're seeing on this GUI, let's first focus on the primary section of this one. Here you see an animation or a comic version of the rocket itself with a couple of our tanks overlaid on top. Those tanks represent our fuel and liquid oxygen tanks. Here you can see the fill level. Obviously, since we're still in captive carry, they haven't decreased yet. Below the rocket, you can see some of the other components that comprise our rocket, like Newton 3, stage 1, inner stage, stage 2, and the payload. Here, we're tracking some of the key parameters like temperature and pressure. Across the bottom of this GUI, you can see some other information regarding both Cosmic Girl and the rocket pertaining to bus voltage, the speed and altitude of Cosmic Girl, which you can see is flying at 420 miles per hour at an altitude of 31,000 feet, as well as our pallet and pylon, which is our separation system for the rocket. So by all means, stay tuned throughout the rest of today's mission and take a look at these GUIs as they update, as they'll provide plenty of information on the relevant section of our flight segment.
Okay, so yes, these GUIs will come when the drop-off will happen. So you will see some sort parameters. Actually, these parameters, if somehow some anomaly happens during the flight, these parameters will be very crucial for us rocket nerds or space nerds to actually decrypt actually what happened at that point of time. Yeah, so in front of you, as he said, we have different parameters: Newton 3, stage 1, interstage, stage 2, and payload. Newton 3 is the first stage engine. The Newton 4 is the second stage. You can right now see the oxygen pump temperature there, Fahrenheit. So everything is right now, it's still not running. So obviously it is not very hot right now, but it will definitely become hot when once it starts running. So you'll have to wait for that time, but the payload is looking good. The Cosmic Girl is moving at around 420 miles per hour and 31,000 feet. The drop-off height will be around 35,000 feet, so kind of hovering over that height only. So yeah, and talking about the LauncherOne, this is a 2-stage rocket. Both of them runs on RP1 and LOX as its fuel. And first stage is Newton 3, second stage is Newton 4, but we still don't have, what should I say, the cycle of this engine. That was one thing which I was trying to find, but I was unable to find that. So I think that's a mystery for us. Maybe some little more digging will enable me to find something about it, but right now it's still just, wow, those views are amazing. Mojave Desert, right? The launch pad for the Virgin Galactic as well as for Virgin Orbit now. One of beautiful deserts that I have ever seen. After drop launch, rocket duration flight is 14 minutes. See, the first stage burns for around 3 minutes and the second stage burns for around 6 minutes. So that's the burn time, you say. and duration of the flight is still unknown for me, but 14 minutes actually makes sense. So let's see how the thing will unravel. What is the purpose of this mission? See, this is not a science mission. This is a commercial mission. So there are certain payloads going on with the mission, and this is the 4th launch of the Virgin orbit. Okay, so and they are trying to get 3rd successful flight. They have already done 2 successful flights. Now they're trying to do the 3rd successful flight, and obviously this is a very new company, a new rocket company which has come into existence. So there are certain chances of ruds happening here and there. Like SpaceX also had issues during the initial days, but now everything is good. So something can happen. So we can't just disregard the possibility of those things. But again, this is rocket business, and they know everything needs to be double checked, and that's what they have done. And talking about the payloads, there are like 7 payloads going on. One is from Department of Defense, or you can say 3 are from Department of Defense. One is from Satrev, and one is Steam Jet. I'll talk about those. She's a beautiful girl. Okay, so Toby, as I was saying, the purpose of this mission it has uh, 3 types of payload, or 3 different customer: Department of Defense, Satrap, and Spire Global, and there is one more, Steam Jet Space.
So once again, what we just saw was Cosmic Girl taking off. That actually happened at 1:38 PST, so that happened a little bit earlier today. But I'd also like to take this time to give a shout out to our flight crew. We have 2 pilots flying, Eric Bibbert and Matthew Stanley Standard, as well as 2 launch engineers. So thank you all for your hard work in making sure our rocket gets to the drop point.
Guys, if you haven't liked the stream till now, this would be a good time to like it, because yeah, if you like the stream, like the information which I am giving, and if you like me as a host, you can just give this stream thumbs up, because it will certainly help tell YouTube that something is going on in here and recommend people. So yeah, that is a small step from you. If you can do that, that would be great. And okay, so what I was saying, yeah, the payload. So talking about the payloads, the most interesting one is the Steam Jet payload, which is a rocket thruster, or you can say a thruster going into space, and that is again the tech demonstration one. But what is interesting about this thruster is that this thruster is okay. Yeah, so this thruster is water based, which means it uses water as its fuel, and as the name suggests, it's a steam jet engine. So the steam will be used for providing thrust, and that thrust will be used for CubeSats, small sats, and all those things. So this is a affordable and reliable one which they have made. One of, for the CubeSats, it is literally known as tuna can thruster. So yeah, and now we are actually approaching.
Seeing expected losses at the point we are in the flight. All ground stations are operating as expected at this point.
Copy. transmissions acting as expected.
Yeah.
Okay, so as soon as it hits that red line, it would mean that this is in operation. Means the drop off is imminent. So we'll see those things happening soon in 18 minutes or so. Whoa, that's a question. How much is a winged Sierra Nevada Dream Chaser space shuttle ticket on Virgin Orbit booster from California to Australia with burn cycle of 3 minutes and 6 minutes after max Q? This is a thing which you want to have, which you desire, to happen, but it won't happen at all. So, can't answer this question. Can Virgin Orbit put a further stage on the rocket to reach Moon or the Mars? See, they have right now their motive for, again, every company has one motive, and right now the motive for Virgin Orbit is to provide space access to everyone.
The drop point. I wanted to give you a quick rundown of the flight profile you'll see our rocket complete today. To help visualize the flight path of the rocket, we have put together a little graphic for you. Once again, to start this segment of our mission, you will hear the pilots yell, "Release, release, release," when we're prepared to drop the rocket. 3 seconds after drop, we will ignite our propellant settling thrusters, followed shortly by our main engine start, which will pitch our rocket up and take us through the stage 1 flight phase. Through the next 150 seconds, our rocket will go from subsonic to hypersonic speeds as we climb up in altitude until we're about 5G in acceleration. At this point, the main engine, or Newton 3, will throttle down until all of the propellant has been expended, and we will transition to main engine cutoff, or MECO. Post-MECO, we'll go into a short coast until it is safe for stage 1 to separate away from the rest of the vehicle. Post-stage 1 separation, the rocket's second stage engine, or Newton 4, will begin its first run phase. At this point, we will have reached a huge milestone for our mission and will have made it to space. This will also mark a point where it will be safe to do fairing separation and set up our system for payload deployment. Around 500 seconds after the start of this portion of flight, we will have reached our transfer orbit and the second engine will cut off and end this first run phase. Next, we will see the vehicle enter into a maneuver we call the barbecue roll in order to ensure proper thermal balance across the vehicle. From here, we'll fly for about 30 to 45 minutes until we reach the apogee of our transfer orbit. Once we reach the desired point, we'll reorient the second stage for a quick second run phase of the Newton 4. This point will be very exciting as we have reached the final desired orbit and we will be ready to deploy the payloads for all of our eager customers. As we're flying and progressing through our mission, we'll definitely try to call out all of these milestones.
Now, Spencer, you are an aerodynamics engineer by training, and I know you love NASCAR and you love all things fast. So, I want you to kind of geek out for a little bit here. So, tell us more about just how fast is LauncherOne going to be flying, and, for an air launch system, what are some of the unique challenges with the early stages of that flight?
Oh, definitely. You're giving me a chance to be an aero nerd. So basically, from an aerodynamic standpoint, we break this up into 4 segments of flight, really. The first segment of flight is a separation away from Cosmic Girl, and we want to ensure that we have this correct because we want to make sure our pilots and the launch engineers flying Cosmic Girl today are safe. So we actually did work with NASA Ames and NASA Armstrong ground to make sure that we had safe separation down and ready to go. From here, we actually go into our, about, as I mentioned, 3 or 5 seconds after drop, we ignite our thrusters and we go into the subsonic flight regime. This is around Mach 0.6. Here we see some challenges like flow separation and vortices along the length of our rocket. From here, we travel from subsonic to supersonic speeds, where we then have to begin to worry about shock propagation along the length of our vehicle and making sure that we can control it through this phase. After this, we go into hypersonic speeds, where we have to take in consideration thermal effects as well as other flow dynamic effects as well.
Wow,
Now,
that's
Spencer,
a
I heard you
cool
mention a
explanation out
barbecue
there.
roll. Is anyone else hungry, or did I just miss lunch?
Ooh, what's your favorite? Texas barbecue or Carolina barbecue?
You know, I've never had Carolina barbecue, so I'm going to go with Texas for now. But anyways, getting back to it, the barbecue roll. So it sounds like a very technical aeronautical terminology there. What is it, and why do we do it?
Right, so it's simply a slow spin about the roll axis. So LauncherOne will orient itself and slowly spin for what we call passive thermal control. So with respect to the position of the sun vector, we want to make sure that components on that second stage and our payloads don't get too hot or too cold, and so we slowly rotate, just like a good barbecue.
Man, that does make me hungry. Now I'm definitely going to have to go look on a food delivery app and see what the closest best barbecue is around here.
We'll be right back.
Okay. So, talking about the barbecue roll, as he said, yes, it is kind of like that only. There is like one heat source coming at one direction, so there's like sun in one direction, and the heat coming from the sun actually heats up that part which is exposed to the sun and not the other part. Because of that, there is a temperature difference, and we don't want that. So we literally try to fry the rocket in sun, kind of, you can say. That's why that maneuver is known as barbecue maneuver. Okay, that's great. So yeah, I was talking about, can Virgin Orbit put a further stage? It can do it theoretically, but again, it has some limitations for according to the the plane. So I don't think so they will have that happening anytime soon. So yeah. Yeah, I do need a new PC out there. You can, that would be great. What specs the plane do? What I you need to know the specs of the plane or what? It's a Boeing 747. That's it. That's all you need to know. It's a Boeing 747, the most common and reliable airplane, as they say. So yeah. Will this be visible from Los Angeles? We see this is further out in the Pacific Ocean. So you might not be able to see this one. And it's a very tiny rocket too. So yeah. Until and unless you literally know where to look in the sky, you won't be able to see. So everything is looking good. We are approaching T-minus 10 minutes mark. So we are getting in close for the drop-off time. Everything is looking good right now. So when are you going to start working on your own space tech, Jacob asks. Okay. So see, this is a question which I would say right now it's very, 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 very initial state. But this is my dream that I would like to put something in space, not by myself, but something which I have made and is some electronics, I must say, maybe which I have made and can be put up into space. But right now my focus is not on that, but that will definitely happen. So research is going on, I must say that. Could a Lockheed Martin ASRG isotope electric generator of 55% efficiency be fitted in satellites launched by Okay, so you mean to say that nuclear isotope, right?
Launch, we thought it'd be a wonderful opportunity to celebrate the innovators we work with in the Virgin Group history, which of course all started with music at Virgin Records. Above the Clouds is a single by the artist duo Gangstar on their hit album Moment of Truth, which was released by Virgin Records in collaboration with New Tribe Records in 1998. We named this mission Above the Clouds to pay homage to Virgin Records, the company that started the Virgin brand. We went around the factory here in Long Beach and let some of our teammates listen to the song. Let's hear what a few of them had to say about it.
Okay. Can't play this song right now, but
albums that were released on Virgin Records, but this is exciting because he even talks about going into space on this song too, so.
okay, so again the timer has updated.
I was a kid, so this takes me back a long way.
High school, we were spinning this at house parties and really enjoying the underground atmosphere that Gangstar provided.
Infinite skills create miracles. Yeah, that's stuck into my head.
My favorite producer, that's DJ Premier. My favorite MC, Guru, rest in peace. My favorite Wu-Tang member, also featured on the track, Inspect the Deck.
Oh, I like the music. The beat is pretty good. Upbeat, love it.
Gangstar, Wu-Tang. I spent most of my time just on the beach and listening to this stuff, so reminiscing, and I just don't think they make music like they used to, so.
It's awesome, you know, it's not every day that a company does something cool that involves hip-hop.
Good beat. And a dance beat, because it made me move. And if something makes me move, then it's good. So, definitely a thumbs up.
I think my daughter would be very proud of me that I'm in it, and I'm not like, you know, I'm not a boomer, but she says, "Hey, boomer," you know. And they can stop calling me office grandpa in the office because now I'm hip.
Gangstar are loving it.
Okay, that's a
I like it. That's a great song to name our next rocket after. We're going to be successful just like the song was.
And I just want to say it's an honor to pay homage to Gangstar in this next launch.
So let's keep playing on. Go Virgin.
Okay, so that was it. Above the Clouds, have you ever listened to this song? I haven't, but I would now. So yeah, I was saying, could a Lockheed Martin the isotope electric generator be fitted inside this to launch nuclear capable satellites? You need to have that rating.
Signal containing key mission information for Mission Control Center operators back in Mojave. So shown on the screen now are the locations of the ground antennas that we will use to capture this telemetry stream broadcast by the LauncherOne rocket on its way up to orbit. Telemetry is on a radio frequency or RF signal containing critical information about LauncherOne subsystems, performance, and the environments that LauncherOne and its payloads will be experiencing during the various phases of flight to orbit. And the ground station shown on this graphic here will receive that signal and send the data on that signal to our Mission Control Center for monitoring, processing, and to that rocket status GUI that Spencer has been showing us here on this live stream.
Okay. So yeah, as I was saying that there is NASA has this thing whenever you want to launch some nuclear related stuff, you need to have that nuclear rating onto your rocket. And right now only rocket which have that nuclear rating is Atlas V, and that's why whenever NASA wants to launch something having a nuclear isotope in it, it uses Atlas V. Because it's only rated for that. It is the only vehicle rated for that. And talking about can Virgin Orbit be rated, maybe it cannot be rated for those nuclear sats, but it is not necessary in low Earth orbit, and range is only the low Earth orbit, so it is not necessary because you can go away with solar panels and they are much more effective in low Earth orbit. So yeah. What does the plane do? Plane is assisting in final checks. So let me just update my timer. Still t minus 10 minutes. So they are updating it again and again. Let me also do that here. Check. A very hectic task to actually update all those things, because I have this this what did I say, yeah, this timer, this t minus. Okay, this is a thing which I have not said in my live stream till now. Yeah, but that t minus timer which you are seeing on your screen, that is actually literally I had to code it, have that t minus timer in the stream. I had to literally write a code to have that type of timer in there, because you don't usually get a t minus timer which counts 0 and then counts above also. I literally had to code it, and that's why whenever the time changes, I have to literally change the time in that code and then rerun that code again. So it takes some time out. You don't notice it, but that's something which is going, one of the things which is going in the background. Okay, so we are right now t minus 7 minutes, d minus 7 minutes, and hopefully things are looking great. As you can see right now, the cosmic gulf speed is also increased to 500 miles an hour. It is cruising at around 31,000 feet. So we are approaching the final time, final 7 minutes until this thing just go whoosh, right? If you want to send a replacement helicopter to Mars, you would rather do it with normal rockets like Atlas V, Falcon 9, or even Starship. Why to have that from Virgin Orbit, right? Makes much more a normal rocket. Yes, it can carry only 300 kilograms to 500 kilograms to the orbit. the drop time is changing, tends to change because the situation at that point of time changes. When the plane arrives to that location, it actually assesses the situation. It's a launch pad out there, so it needs to assess that situation and accordingly do some rolls or U-turns and whatever maneuvers it want to do. If it is a weather issue out there, so then it has to move on to another locations. Those are the things that happen in the real time at that point of time when it reaches the location. So therefore you might see some changes in the drop off time, but right now I think we are in final 5 minutes. Hopefully we should be seeing this dropping off in just 5 minutes from now. Okay, so this pattern is kind of a standard pattern which all pilots follow when they want to what should I say, circle around one location. But this is kind of more kind of like a not a circle but oval or something like that. So we are d minus 3 minutes. Again I say t minus 3 minutes. We are d minus 3 minutes and 37 seconds. Everything is looking good. The altitude is 31,000. The speed is 46 miles an hour. The altitude is 31,000 feet. Sorry, speed is 100, and hopefully it will increase as we proceed further, and hopefully we will not see any further change in the drop off time. We are d minus 3 minutes. Everything is looking good, and you should hear release call out before the drop off, and once you hear release, you will actually see it releasing from the Cosmic Girl, and hopefully we will be getting some footage from there. What is the launch success percentage? Well, that's a tricky question. This is the third flight, consecutive third flight if they get successful. So third consecutive successful flight if they get successful. So they don't have a very large sample space, so can't say much. Now they are accelerating the speed to increase.
Confirmed rocket is on internal power.
Base copies, rocket on internal power.
The rocket is in internal power. Everything is looking good, and this is the final run to that red line. Once it reaches that red line, there is no turning back. And it's 1 minute. Speed is increasing, as you can see. 522, 524.
Altitude
is increasing.
Port chill is initiated.
Copy, import chill initiated.
Import chill nominal. Rocket systems nominal.
Everything is nominal.
Confirmed to go.
Okay, guys.
Base copies, aircraft S-bin, AFS has confirmed go.
Okay, we are in final 60 seconds. We are in final 60 seconds. Everything is looking great. Go for the launch. Hopefully T minus 44 seconds, 570 miles an hour. 1000 is the altitude right now.
LRC arm initiated.
Okay, minus 20 seconds. Hopefully we get to see some footage. T minus 18, 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4,
Sorry, good morning.
3.
Vehicles in drop ready mode.
Copy, drop ready.
Drop ready. Okay, anytime now. Fingers crossed. You will hear release, release, release.
Ignore warning.
Release, release, release.
Release, release, release.
Drop ready, as we can see.
And it has released now.
The rocket cam for the drop, but we should be able to acquire that telemetry right afterwards and begin seeing.
It has released, guys. But unfortunately, we didn't see the footage.
Looks like we made it above the clouds and onward to orbit.
Base copies, we're above the clouds.
Ah, it's a beauty up here.
Max Alpha flight complete.
Okay, everything has happened, guys. The rocket is on its flight. The rocket has been dropped.
Stage 1 burn nominal.
Stage 1 is burning nominally, and there you go, guys. We have finally the onboard camera footage. This was a bit of glitch, but from the onboard camera also we can't see much, but we can actually see it is burning, so that is a plus sign. You can see the velocity increasing. The first stage is burning right now, 64,000. Okay, everything is looking good. The first stage, the Newton 3 engine is burning as.
Control room, we have switched back to the Long Beach dish for telemetry on this band.
Okay.
Here.
LE1, can you repeat last?
Stage 1 burn. We are level up, and we have a pretty good view up here.
Base copies.
So as you all might have heard on MCC, we were able to drop successfully and separate from Cosmic Girl. We have already passed a number of milestones on our way here. Currently, you can see the rocket is at 3,000 miles per hour. That's around Mach 4, 5. And so we're definitely cruising through. We already made through our supersonic regime.
Okay, guys, everything is looking good. Although the burn plume may just be, that dark plume of the burn may just be because of the camera glare or something like that, but everything else is looking good. See, again, we tend to, disregard the fact that SpaceX tend to provide such a high quality stream, but they literally have all the constellation out there to support it. But when the new launch provider like Virgin Orbit is in there, so we don't seem to get good images or videos, but hopefully we will get something out of when oh, this is space now.
Shutdown confirmed.
Stay step, brake wires broken.
Okay, day separation confirmed. They have reached space.
And amazing views that we're seeing right now. The blue has gone to black And that is the limb of the Earth in view. LauncherOne is in space.
That is a great sign. 0.7 miles in per hour. This is the second stage burning right now.
Fairing brake wires broken.
Fairing separation, and we can actually see that. That's a cool view out there. Yeah, stage 1 has separated. Everything is nominal.
So what
out
you
there.
might have just seen on the video is we just had successful fairing separation from stage 2. And our
Hey, there you
actually,
go.
you can perfectly see the satellites right now. And that's an absolutely gorgeous view of our system in space.
Yeah, look at that. There's our integrated payload stack. Again, to our 7 customers, welcome to orbit. You know, if we have more time in the schedule before the payload deployment, but LauncherOne is in space. What a beautiful sight.
Hopefully.
And we're getting word now that we are having great connection with all of our ground stations.
Okay, so we can see the Newton 4 engine is burning all right. You can see those plume effects. Everything is looking good. The vehicle is at 0.8 miles per hour. Sorry, 8.8 kilo, 8,800 miles per hour. Say it right. Miles and kilometer thing just confuses me. Okay, so the stage 2 is moving as needed, so everything is going as per the plan, hopefully. This some sort of whatever you just saw, those particles in the camera were just the ice flakes, so don't worry about them. Plus 6 minutes and we have the let's just have a look at the GUI and maybe we will get some great knowledge about what is happening. We just try to decode it. Half the
Stage 2
fuel
PU
right
nominal,
now.
halfway through burn.
Halfway. Graph is looking good as expected, although I would love to have that graph, the GUI expanded. Right now everything is looking good, so no worries with miles an hour. We are looking for around 17,000 miles per hour attain orbital velocity. There you go. 37%, that's how like bearing has stated. Pressure, chamber temperature. We didn't get a good view out of it, but it is still accelerating and that's what we want. Yes. Hopefully.
So listening into mission control, we just heard that we're over halfway through our stage 2 burn, as you can see on our GUI on the screen. Here we're looking at some of the information about our stage 2 rocket. On the left side, you can see the gimbling of our nozzle itself and the thrust vector there, as well as the expenditure of some of our fuels, like the fuel and liquid oxygen on board our stage 2 tank. Stage 2 rocket.
Oh, there's a thrust vector also. Well, because of that thrust vector, you can actually. Okay, SECO. Okay. We have a thrust vector, which means we can actually, through the data, we can see if the engine is gimbling or not. So we have SECO right now, but here the GUI says it's still burning. Yes. Not SECO yet. burning.
AFSS mission rules satisfied. 30 seconds to Seco.
Okay, 30 seconds to. Stage 2 cutoff coming in just 20 seconds or so. We 1000 miles per hour, which is like 1000 miles per hour short right now, but it is
Newton 4 shutdown confirmed.
okay. So we have Seco right now, and there will be the second burn also to circularize. So whatever deficit is, that would be covered there.
Okay. Coast started, barbecue roll started.
Okay, barbecue roll has been started. Seco is confirmed. Everything is going as per the plan.
So we just heard from Mission Control that we just shut off Newton 4. So that was our Seco 1. And we've begun that maneuver that we mentioned earlier called barbecue roll.
And now Launcher 1 is going to coast all the way out to orbit apogee. And there, Newton 4 will burn a second time. And after that, we will deploy our 7 customer payloads into that mission orbit.
Okay, so looks like we didn't get much of the footage as we expected, but hopefully we will get some great footage once the Cosmic Girls lands. Cosmic Girl must have recorded it beautifully, how it dropped and all those things. Yeah. And yes, as someone pointed out, there was one plane which was following 747, so that plane must have recorded some good footage too. Hopefully it does look like they have nailed this launch too. It would be great if they can get like 3 successful launches, because that is a great milestone.
Telemetry is beginning to go intermittent on us, man.
Copy that. Estimated LD on control. Go ahead. Looking for permission to release the airspace in the LTRAV.
Don't we need to wait until we're over land?
Whoa, oxygen magically
Do we need
is
to wait till overland?
200% right now.
The answer is no. Our FA rep is chasing.
Oh, okay. Then you're good to release.
Copy that.
That is not supposed to happen. Has anyone gone there? Are there aliens there? Just filled the tank, oxygen 100%. Some glitch out there, right? Okay. So these are the 2 satellites, the Steam Sat 2 and the Stock 3. So this Steam Sat 2 is the one which I was talking about, which I am excited about because it literally has a water thruster on it. We'll have to see how the things would look like. So right now we have loss of signal. That's why you are seeing 0 miles per hour. And this Stock 3 satellite.
Copy, you on control?
Are you good to get going with this?
Yep, can do.
Sounds good. I'm going to be handing over to LC2 here.
Okay. This Stock 3 satellite is that satellite which will be able to monitor the agricultural land. It's an Earth observation satellite against a constellation, basically a constellation of satellites which will be going to space. So this is one of them. and tubular bells was the mission which actually carried off these satellites. So yeah, they're looking great right now. The oxygen down to 4% now. And fuel is 0. Wow. They have to get this sensor read. They are either they are getting the sensor reading wrong, or there is some software glitch. Because the fuel can't be 0% right now if everything is going good. Because they have to do 1 second burn also. Previously the oxygen was at 100%. There must be some this barbecue maneuver must be doing some funny things with the sensors. Might that be the case? It could be the case, right? Yes, Simon, the regarding that music, I tend to mute it whenever is possible. But right now, okay, let me just try to explain you the graph right now. In the top left corner, that is most probably altitude graph or the velocity graph. That must be the velocity graph. So right now it's constant because it is not accelerating. That's why it is constant.
Including confirmation of payload deployment.
We want to thank everyone who tuned in for our Above the Clouds mission today. We also want to thank our customers for flying with us. And a special shout out to our live stream production crew, brand team, and my co-hosts, Paul and Spencer.
I want to also give a special shout out to all the engineers and technicians who I can hear on mission control right now cheering in the background. They have been working diligently and they've been working odd hours to make sure both Rocket and Cosmic Girl were ready to go today so that we were successful for our mission.
We've entered into commercial service and we are delivering on our commitments to our customers because here at Virgin Orbit, we release,
repeat.
Take care.
Okay, that happened, but what about the second burn? You know, they still have to. Okay, this stream was kind of weird, but okay, we'll talk about it. Don't worry. That's how it looked when it dropped it. Okay. For joining us, but right now I have so many questions whether that the reading which we were seeing on the screen was legit or not, or has that burn the second burn has happened or not. Let's go to our Could all Twitter and see what is what. Wait for a second, guys. Okay. The any music recorded in 70 plus years domain. That's I don't think so. I have noticed this thing in Virgin Orbit stream and Virgin Galactic stream, especially that they tend to use Virgin music and they have copyright issues. So that is a thing. But right now, I need to discuss about um, whether this flight is even successful or not. So we got to hear the things and the readouts, but the launch webcast comes to a close and we don't know whether we have the second engine start or what. I'm as confused as you are. Found a successful separation, great connection with all of the ground station. Welcome to space. Other than that, we don't have anything. Okay, maybe this is successful. Might just be a software glitch. So they ended the stream without us seeing the deployment, and that is that they have a valid reason for that, because again, Department of Defense satellites are there, so nobody wants anyone, Department of Defense don't want anyone to see those satellites. Yes, this was supposed to happen. The only concern was that 4% fuel, 4% oxygen, 0%, but I think that's all. So congratulations to Virgin Orbit for their third consecutive flight, although I would say it's like 80% done, still 20% to go. So we'll have to wait and see. And yes, guys, if you are a Expanse fan, it's a sad day for you, because in just 1 hour the series and the Expanse finale is coming up, and after that there will be no more Expanse. And I am a huge fan of the Expanse, and I would recommend you to also see that. All love in all the details and all those things if you are a space fan. Okay, guys, I guess that's it for today. Maybe because we actually don't get to see much of the things, but again, the mission was successful as what we are hearing right now, and hopefully that would be the case every time. Could one of the tanks have overpressure and forced us to burst and lose it all after a second? That is, see, in rocket industry that can I mean, anything can happen, but getting overpressured would be a very, I would say, what should I say, overpressured would not be a term, because helium bottles and the fuel tanks pressure, they are I think fuel tank would be able to handle that pressure until unless there is some kind of explosion, like that happened with the SpaceX when one of the helium bottle actually came in contact with the fuel tank, and the temperature difference caused the explosion. So anything can happen, but right now I don't think so that could happen. See, I don't know what actually happened with Virgin Orbit. there was some glitches for the stream today. The stream actually crashed in between, and then we also saw some glitches, but now everything is good. So they actually got the thing right. The payload is in the orbit, the rocket is in the orbit, and that's what we want, and that's what they also want. So congratulations to Virgin Orbit for their 3rd consecutive flight. And finally they have put the payloads to the orbit, and now I'm looking forward to the performance of that steam jet engine or steam jet thruster, whatever you want to say. So I guess now would be a great time to end the stream. It's almost 5 a.m. here, and not looking in a good shape. I'm very sleepy right now. Must go and take a sleep. And thank you all for tuning in. Really appreciate you all, guys. And if you haven't liked the stream till now, I tried my best to fill all the void in the live stream which the official channel presented. So if you liked what you just saw, give it a thumbs up, subscribe for more. There are many launches coming up in January, so do subscribe for that, and hopefully you will get to see some video too for January ends. Thank you all for tuning in, and thank you all the mods for great moderation work. That's always the case. Without the mods like you, I wouldn't be able to moderate the chat and keep it civil. So thank you all for that, and thanks all my Patreons and members for keeping the support, giving me all the support. And finally I'll be able to have some sustainable income, because one of the member Madhvil has become a member in Astronaut Tire. That's a great one. Thank you for Mohammed for you becoming a sponsor for this channel, and thank you all my Patreons and members, and I will hopefully see you on 18th of January with another launch, and that would be of Astra, and hopefully Astra will be launching some sort of payload this time, and we won't see those funny maneuvers that happened during the first attempt. So thank you all for tuning in. This is Pianshurula. You just saw Rocket Gyan. Stay safe, stay healthy, and bye-bye.